Hello learners, this is Dr. Krishnaveni giving you a lecture on types of numbers. In this lecture, we will see natural and whole numbers, integers, rational and irrational numbers, even and odd numbers, prime and composite numbers. What are natural numbers? We all know that the numbers 1, 2, 3, so on up to infinity are called as natural numbers. The numbers starting from 0, 0, 1, 2, 3, so on up to infinity are called as whole numbers. And if you see whole numbers together with minus 1, minus 2, minus 3, up to minus infinity, all these are called as integers. And see, in integers we have 1, 2, 3, 4, so on, which are called as positive integers, minus 1, minus 2, minus 3, so on, which are called as negative integers. In between there is 0, and this 0 is neither positive nor negative. Now, if a and b are two integers, and when you write a by b, where b is different from 0, you will get a rational number. So any number of the form a by b, where a and b are integers and b, which is in the denominator, is different from 0, is called a rational number. For example, here 2 by 3. 2 is an integer, 3 is an integer, and 3 is not 0. So it is in the form integer by integer, where the integer in the denominator is different from 0. Such numbers are called as rational numbers. And if you see here 4 is also a rational number. Why? Because 4 is written as 4 by 1, an integer by integer. 99, of course, minus 99. It is also a rational number because it is written as minus 99 by 1. 0 is a rational number because 0 is equal to 0 by 1. So this justifies that all integers are rational numbers. So if you are given an integer by 1, if you put, it becomes a rational number. So apart from those, we have rational numbers which are not integers. They are in this form: 2 by 5, 7 by 9, 8 by 11, 25 by 12, etc. All these are rational numbers which are not integers. This way you have infinitely many rational numbers. See, rational number you have seen which is expressed as a fraction, integer by integer. Now, if you write that is the decimal form, if you see 1 by 5, it is a rational number because an integer by integer, and it is in the form 0.2, which is a terminating decimal. 1 by 4, it is 0.25. It is a terminating decimal. 1 by 8, it is a rational number, and when you divide 1 with 8, you get 0.125 in the decimal form. And all these forms are terminating decimal forms. When you come to 4 by 9, 4 by 9 means when you divide 4 with 9, you get 0.44444. This is a repeating decimal form which is non-terminating. Okay, so non-terminating repeating decimal forms also called as rational numbers. Means a rational number is, if you express in a decimal form, it is either in terminating decimal form or non-terminating repeating repeating decimal form, which is non-terminating. Okay, and all these are rational numbers which are infinite in number. Now a rational number, if you have a number which is not a rational number, then that is called as an irrational number. So irrational numbers are also infinite in number. Now if you see the difference between rational and irrational number, here root 2, if you find the value of root, it is 1.474, it is non-terminating. Okay, non-terminating. It is, if you write in the decimal form, it is non-terminating and of course non-repeating also. Whereas in case of rational number, the decimal form, it is either terminating decimal form or repeatedly non-terminating decimal form. Okay, whereas here non-repeated decimal forms. So all these are coming under irrational numbers. So basically a rational number which is not a number which is not a rational number is called as an irrational number. And you have seen pi e value. Now if you see in calculator also, the v value would be like this. And what it is in the decimal form, which is non-terminating and non-repeating decimal form. And pi is also 3.141592654. It is non-terminating, non-repeating decimal form. So non-terminating, non-repeating decimal forms type are called as irrational numbers, whereas terminating and even non-terminating repeated decimal forms are called as rational numbers. So the rational numbers, irrational numbers together constitute real numbers. So all rational numbers and irrational numbers are called as real numbers. And if at all I say number means it is a real number. Any real number lies between minus infinity plus infinity. So number that lies between minus infinity plus infinity is called as a real number. So these are the examples of real numbers, means all natural numbers, integers, rationals, irrationals, they are all real numbers. See, real numbers you can express either in fraction form or in decimal form. Okay, and real numbers are infinite number. Now what you learned so far is a rational number is a terminating or non-terminating but repeating decimal. If at all it is non-terminating, it is a repeating decimal form. Whereas irrational number is non-terminating and non-repeating decimal. All rational numbers and irrational numbers constitute real numbers, and there are infinitely many real numbers. So you have seen natural numbers, integers. Of course, in between there are whole numbers. Integer by integer gives you rational number. A number which is not rational number is called as an irrational number. Rationals, irrationals together will give you real numbers. Now, another category of number, if you see, imaginary number. See, if you know, square root of a negative number is defined as an imaginary number. See, here square root of -1 is defined as I. I stands for imaginary. When you square on either side, you get -1 is equal to I square. So here I stands for imaginary number, where I square is equal to -1. So we all know square root of 16 is plus or minus 4. Now when you have to find out square root of -16, what you have to do is, this -16 means -1 into 16. So 16 into, in place of -1, we write I square. So 16 I square means -16, because I square is equal to -1. Now square root of 16 I square is written as plus or minus. For 16 square root is 4. For I square root is I. In a similar way, suppose square root of -221 you want. This means 221 into -1, which is equal to -221. So 221 into -1. In place of -1, we will write I square. So that it is square root of 221 I square, whose square root is plus or minus 221 square root means 11, because 11 11s are 221. I square is square root of I square is I. So whenever there is I involved, we call that number as an imaginary number. So these are the examples of imaginary number. See, 1 by 5 into I, minus 13 by 8 into I. I gave you different types of numbers here, okay, with the fractions, without fractions. So now you are ready to define complex number. A number of the form a plus ib or a plus bi, where a and b are real numbers. You have seen what a real number is. And I is imaginary, means I square is equal to -1. So any number of the form a plus ib, where a and b are real numbers and I square is equal to -1, is called as a complex number. Okay, so here we will see some examples. 9 is a complex number. In fact, 9 is an integer. In fact, 9 is a natural number. It is an integer. It is a rational number because 9 by 1 you can write. Now it is a real number also because any rational number is a real number. But now you are saying that it is also complex number. If it is to be a complex number, what I said, it should be in the form of a plus ib. Is it in the form of a plus ib? Yes, because 9 you can write it as 9 plus 0i. 9 plus 0i. Here 9 is real part, 0 is imaginary part. Okay, here for 9 the real part is 9, imaginary part is 0. So whenever a plus ib is a complex number, I said a and b are real numbers. Here a is called as real part of the complex number a plus ib and b is called as imaginary part of the complex number a plus ib. So this is how you can say 9 is a complex number. 0 is also a complex number because 0 you can write it as 0 plus 0i. Here real part is 0, imaginary part is 0. 18i, when you say 18i can be written as 0 plus 18i. Here a is 0, b is 18. The real part is 0, imaginary part is 18. If you take minus 2 by 5, minus 2 by 5 is written as minus 2 by 5 plus 0i. Here real part is minus 2 by 5, imaginary part is 0. So any number of the form a plus bi is a complex number where a is a real number, b is a real number. So this shows that every real number is a complex number, but you have complex numbers which are not real numbers. Okay, 18i is a complex number. Whereas 9, 0, minus 2 by 5 are real numbers which are also complex numbers. So here down if you see some examples, 2i is a complex number. 11 is a complex number which is also a real number. 7 by 15 is a real number which is a complex number. If you see minus 7i, it is a complex number which is not a real number. So 4 plus 6i, minus 8 plus minus 35i, these are all complex numbers. And see, because they have real part and imaginary part, and some of them are having only imaginary part. Okay, so every real number is a complex number, but some complex numbers are not real numbers. Now, if you come to know this is the number system, girls. The basic thing from this is the complex number set is the bigger set. See, you know that every real number is a complex number, but not all complex numbers are real numbers. Okay, so every real number is a complex number, and real numbers are nothing but rationals and irrationals. So here you have rationals and here you have irrationals. Again, rational means you know every integer is a rational number, and rational numbers also are in the fraction. Like I told you, every integer is a rational number, and some rational numbers are there which are not integers, which are in the form of fractions. And you have seen that a fraction is of different kinds. There are, in fractions you can write them as decimals, and in decimals again you have different category. One is terminating decimal, other one is non-terminating, non-repeating decimal, and other one is non-terminating but repeating decimal. Okay, so rational numbers are integers and fractions which are not integers, and in fractions we have decimals, and decimals are of mainly three categories. One is terminating decimal, other one is terminating, non-terminating, non-repeating decimal, other one is non-terminating but repeating decimal. Okay, so all these fractions, decimals, terminating, they all come under rationals, and even non-terminating repeating numbers also come under the category rational numbers only. And if you see decimals, non-terminating, non-repeating part, they come under the irrational numbers. Okay, this is what we have seen in the previous slides. Okay, you know that natural numbers, and when zero is included, we call them as whole numbers, and whole numbers together with negative natural numbers are called as integers. Okay, let us see two different type of numbers now. This even number and odd number. A number which is divisible by 2 is called as an even number. We will go for a simple definition. See, if at all any number is ending with either 0 or 2 or 4 or 6 or 8, and we can immediately say that it is an even number. Okay, see here this number, if you see 23170, this is an even number because it is ending with 0. Here 0 is in the units place, and 8976 is an even number because 6 is even and it is in the units place. That is, this number is ending with 6. 534 is ending with 4, or we can say the units place is 4. Okay, and here 32, the units place is 2. So if at all the units place of any number is either 0, 2, 4, 6, 8, or any number ends with these, we say that that number is an even number, and any number other than even number is called as an odd number. Even numbers are divisible by 2, whereas odd numbers are not divisible by 2. So here are the examples for odd numbers like 1, 23, 745. See, these are not ending with 0, 2, 4, 6, 8. So these come under odd number category. Another type of number is prime number. If you see this number 2, 2 is factored as 1 into 2. And 3 is having two factors 1 into 3. 13 is written as 1 into 13. See, if you see here, the factors of 2 are 1 and itself. The factors of 3 are 1 and itself. The factors of 13 are 1 and itself. Okay, so a number which is not equal to 1 and whose factors are 1 in itself is defined as a prime number. Okay, so a number which is different from 1 and whose factors are 1 in itself is defined as a prime number. So prime number examples are 2, 3, 5, 7, 11, 13, and I wrote them in order actually speaking, and here 2 is the only prime number which is also an even number, and remaining prime numbers are all odd numbers. Okay, so the least prime number is also 2, which is an even number. See here, 1 is actually is neither a prime or not composite number, that you will come to know. Now here few more prime numbers. 29 is a prime number because you can write 29 as 1 into 29, no other way. 53 you write it as 1 into 53, and 89 is also 1 into 89. So because the only factors of these numbers are 1 and that those numbers so we say that they are prime numbers. Now a number which is different from 1 and which is not a prime number is defined as a composite number. Okay, a number which is different from 1 and which is not a prime number is called as a composite number. See, for example, 24. 24 is a composite number because 24 is factored in so many ways. See, 24 is 1 into 24, 24 is 2 into 12, 24 is 3 into 8, 24 is 4 into 6. See here, apart from 1 and 24, there are so many other factors of 24 like 2, 3, 4, 6, 8, 12. So the only factors of a number are 1 and itself. In that case, we say that it is a prime number. But apart from the number 24 and 1 as factors, we have so many other factors for 24. Therefore, 24 is not a prime number. Thus, it is a composite number. If you come to number 81, this you can check, girls. The factors of 81 are 1, 3, 9, 81. Okay. See here, actually, 9 nines are 81. So 3, 3, 3, 3. So the factors of 81 are 1, 3, 8, 91, 81. Apart from 1 and 81, we have two more factors for 81, namely 3 and 9. That's why it is not a prime number. It is a composite number. Now few more examples are here. 18 is also a composite number because 18 can be written as 1 into 18, 2 into 9, 3 into 6. See here, apart from 1 and 18, we have 4 more factors for 18. That is why it is a composite number because it is not a prime number. So 21 is also a composite number. You can check, girls. And here few more examples for composite numbers are given. So what we understood so far is 1 is neither prime nor composite and 2 is the only even number which is prime. All prime numbers are odd numbers only except 2. So 2 is the only prime number which is also even, and you have infinitely many prime numbers. Now coming to this part, this is fundamental theorem of arithmetic. What it says is any integer which is greater than 1 is expressed uniquely as product of prime powers. See here 180. This is an integer. You know that it is greater than 1. It is certainly greater than 1. And now what I did here is 180, I wrote it as 90 into 2. And again 90 is not a prime, no. So I wrote it as 45 into 2. And 45 is also not prime. I wrote it as 9 into 5, and 9 still is not prime, which is written as 3 into 3. Finally, you got 180 as product of, see, prime numbers. 2 is a prime number, 5 is a prime number, 3 is a prime number. So there are 2 3's, so 3 square. There are 2 2's, 2 square, and there is 1 5, 5 power 1. So finally, 180 is expressed as product of prime powers. This decomposition is called as prime factorization, also called as canonical decomposition. So this is applicable to any integer which is greater than 1. Given integer greater than 1, you can always write it as product of prime powers, and this is called as prime decomposition or prime factorization, and this theorem is called as fundamental theorem of arithmetic. Arithmetic means it is a branch of mathematics which deals with numbers. Now see, this will make you understand what exactly an integer is. In integers you have even numbers, odd numbers. In integers you have prime numbers and composite numbers. What are integers? 1, 2, 3, 4. They are all positive integers. 0 is an integer, and you have the other end -1, -2, -3. They are all negative integers. And in these we have even numbers, odd numbers, prime numbers, and composite numbers. So we are coming to the end of the lecture. Sometimes while doing the problems, you will come across with situations like consecutive numbers. Whenever they say to take consecutive numbers, you can take the numbers as n, n plus 1, n plus 2, n plus 3. And if I say that to take consecutive even numbers, you can take the numbers as n, n plus 2, n plus 4, n plus 6 if n is even. Whenever n is even, n plus 2 becomes even, very next integer which is consecutive, like that. See, suppose for example 4. 4 is an even number. So 4 plus 2 6 is the very next even number. 4 plus 4 8 the very next even number. 4 plus 6 10 even number. So 4, 6, 8, 10 becomes the consecutive even numbers, like that. Suppose if you are asked to take consecutive odd numbers, in general you can take them as like n, n plus 2, n plus 4, n plus 6, where here n is odd. Okay, so you can check this. If n you take 3, 3 plus 2, 5, 3 plus 4, 7, 3 plus 6, 9. So 3, 5, 7, 9, etc. These are all consecutive odd integers or odd numbers. So in general, we take 2n, which denotes the even number, and to denote an odd number, we take it as 2n plus 1. So when n is 0, 1, 2, 3, so on. Okay. With this, we come to the end of the first lecture. Thank you.